So hello people, today we'll be solving LeetCode daily question 621, that is task scheduler, and in this we'll be given an array of CPU tasks represented by letters A to Z and a cooling time N, and each cycle of interval allows the completion of one task, and tasks can be completed in any order, but there is a constraint that identical tasks must be separated by at least n intervals due to cooling time, and we have to return the minimum number of intervals required to complete all tasks. So for example, in the first case, we are having task as A and then B, and we need to have at least two intervals between the same task. For example, if we'll start with A, and then we need to have two intervals. Let's say we are having yeah. If we are starting with A, then we need to wait for 2 seconds for two intervals, basically not 2 seconds. So then we can again do a and then we'll be just let's just copy the sequence, and then only we can do the rest of the task, and then again we'll be having to do okay. So this is a sequence which we can follow, and also we need to complete B task. So if we can, or there is also option to start B after this, we can start B immediately after this, then B, and the sequence will remain the same again up to this point. Okay, and then B, and then here it should be B, then we'll be completing B, and at the end also we'll be again completing B, but we need to return the minimum number of intervals. So what we can do is, we know that even after starting with B, we need to wait at least two to do a B again, because that's as per the standards that there is a constraint. We need identical tasks must be separated by two intervals. Okay, so sorry. Yeah, now what we'll be doing is, we'll be picking up this B and we'll be replacing it here. Now we are having interval, we are having A, and then and first interval, second interval, and then again A. Then here also we can replace it with B. Then also we can see that in B also this pattern is for the first interval, second interval, and then B only. And now we'll be having an ideal space, then again A, and then here at last B, and we'll be not having to do rest of the work, so it will be completed by now. And the total number of intervals which were needed are, this is counted as 1, 2, 3, 4, 5, 6, 7, and 8th interval. Okay, and 8 is the output, which is the number of intervals required to complete all the tasks, or let's say the time at which we'll be ending the all of the tasks. Okay, and for example, in the next test case also, we can have a look that we are having two A's, then two A's, one C, one D, and then two B. So we'll be following the same pattern again, that A, B, C, D, and then A, B, because it states that at least an interval should be there, not exactly or something else, or at most. So this is how we will be doing. And but in the third test case, we are having that n is equal to 3, so we'll have to wait for 3 intervals after completing a task to follow an identical task. So for this, what we'll be doing is, we'll be picking up the task which will be having the most frequency, and we'll be sorting all the frequency array based on that, the maximum frequency will be the task with which we will be starting. And then what, for example, if I am starting with the task A, currently my time is 0, and the pending tasks are 3, and then for B the pending tasks are still 3. I'm going with this example only, the example 1. And now let's say I have sorted the value, so my priority queue, or let's say the heap, will be like this only, 3, and then it will be bounded with 3 again, 3. And then for example, let's say what I am having is, I'll be having a queue. Okay, so queue, it will be storing my cooling time. So for example, every time I'll process a task, I'll be adding it to the queue, and I'll be popping off only if at my current time is same as the time with that is required to do the task again. Okay, the same task again, like, okay. And this is the cooling queue, and this will be currently empty. What I'll be doing is, I'll be moving it to my heap, and for example, I'll be popping off the A task. Let's say A or B, anyone can be popped. If I'll pop A, so I have processed A once, and my current time will be now 1. And now my A's remaining tasks are 2. So what I'll be doing is, I'll be appending this A to my queue. That is, now my current time is now my remaining count of A is 2. And then I'll be also having a time that again, after two intervals I can access, that is n, I'm having two, so at time, oh sorry, currently at time 0, so after 2 seconds, or let's say the time 2, I can access this task again, so I'll be adding it 2. Okay, now what I'll be doing is, now I'll be incrementing my time. So my time is, let's say, when I'll be accessing the B task is 1, and now I'll be popping out the B from the priority queue, and my B's remaining count will become 2. And what I'll be doing is, then I'll be appending this B to the queue, and that will sum up to that my B is remaining task are 2, and the current and the time after which I can access B again, I'll be adding n to it, that is 1 plus, okay, I'll just do n, this is n or 2 we can say, and again n or 2 we can say. So at time 3 I can access the task again. Okay, and now what I am having is, at time 2, what I'll be doing is, I'll be checking again that if I can, if it is possible for me to, okay, I'll be popping off from the queue, that is, let's just pop it off from the queue, and now my A will be having remaining tasks as 1, and after accessing it at the current time, the next time I can access it will become plus n, that is n or 2, that is, I'll be adding my 4 into it, that is a 4 and then 2, oh okay, sorry, 8 1 and 4, and now at the time 4 I can access it. So this is how I'll be going in across all the frequencies. So now let's start towards coding it, and then we'll have a character to store the frequency, character of and let's call it map, that is equal to new hash map. And then what we'll be doing is that for character ch, and for, let's say, character task and tasks, I'll be updating the map, that map dot put task comma map dot get or default task comma 0 plus 1. Okay, now what I'll be doing is, I'll be having a priority queue, or let's say a queue only, integer, and let's call it max heap, that is equal to new priority queue, and we'll be adding a custom comparator over it because we need a max heap b minus a, and then I'll be adding all the frequency values to this, that is max heap dot add all map dot values. You can do it manually also, but I'm just using add all function. And then let's have a queue of integer, that will be called it as, oh sorry, queue of pair, because here instead of adding a pair we can just create another class pair, that is, here we'll be having the count and the time when which at which we can access it. Okay, so now int will be initializing this constructor, that int count and int time, that this dot count is equal to count, this dot time is equal to time, and then we'll be having a queue of pair, let's call it the cooling time, and cooling only will work, that is equal to new linked list. And then what we'll be doing is that while not max heap is empty, dot is empty, or my queue is empty, because we need to process all the frequencies or the task, basically, not cooling dot is empty. And what we'll be doing is, I'll be just popping okay, let's have a time variable also, int time, that is initially 0. I'll be incrementing the time plus plus, and I'll be having the count of the remaining things, remaining task, that is, I'll be popping out from the queue, that is okay, so if not max heap, we'll need to add a check that is empty. We'll be popping out from the queue the task with the maximum frequency, that is int frequency, let's say, that is equal to max heap dot poll, and we'll be decrementing its frequency by 1 minus 1. Okay, so by now we have updated the frequencies array, and we have, oh sorry, the frequency map, the we have created the max heap, the cooling queue, and now we'll be just having to update this. And now let's do, we'll be checking that if frequency is not equal to 0, that means we haven't accessed all of the remaining the task at all, like the total count of the count of the frequency of each task. And then what we can do is we'll be just adding it to the queue, that cooling dot add the current frequency and my current time plus the nth time plus n. Okay, and now what we'll be doing is we'll be checking that if not cooling dot is empty, and here I'll be checking is that cooling dot peak, will be adding it to the queue only and only if my current time and the time when a task was scheduled to be accessed again is the same. Dot time is equal to my current time, then only I'll be adding it to the queue. Oh sorry, here I need to add to the queue also new pair. uh, yeah, new pair. And now what I'll be doing is I'll be adding it to the queue here, max heap dot add the frequency of the cooling dot pool and dot count. Okay, and at the end we'll just have to return the return time. Okay, now let's run it. Yeah, and it gets accepted. Now let's submit it, and it works perfectly fine. Okay, so this was for today. Thank you for watching.